Good evening, everyone. Thank you for joining us today. If someone on YouTube can quickly confirm if I'm audible. All right. Thank you for the confirmation. Once again, good evening, everyone, and welcome to another session of the Formula Bharat Academy series. Today's topic is one that lies at the very heart of motorsports engineering: vehicle dynamics, suspension, and chassis design validation through simulation. And to take us through this exciting journey, we have with us Mr. Matheshwaran, Solutions Engineer at IPG Automotive India, a company that's a global leader in virtual test driving and simulation solutions, and a proud solutions partner and sponsor of Formula Bharat 2026. Before we begin, a quick note for our audience. This session is being live streamed live on the Formula Bharat YouTube channel. Feel free to drop your questions in the live chat, and we'll be taking them up during the Q&A segment at the end. Without further ado, I would like to hand over the session to Mateshwara.
Hello everyone. Yeah, I think I am audible. So without delay, we will start the webinar. So in this webinar, we are going to discuss about vehicle dynamics, suspension, chassis, design validation through simulation. So you're from Formula Bharat, a racing team building racing cars. So you know the importance of vehicle dynamics and suspension and chassis design validation. So without delay, we will start. So we at IPG Automotive trace our roots back to 1984 when the company was founded as a spin-off from Karlsruhe Institute of Technology. We were among the early pioneers in vehicle dynamics and hardware in loop simulation. IPG Automotive has grown into global leaders in virtual test driving, helps engineer, design, test, and validate vehicle faster and more efficient. So our simulation and testing solution are built to help the growing challenges of automotive development. That's why we follow a system engineer approach, which is characterized by development and testing of complete system. Through virtual test driving, we bring this idea into action. We can simulate full vehicle behavior under realistic driving scenarios. So our application lies under powertrain, vehicle dynamics, autonomous vehicle, ADAS. So this webinar is going to mainly focus on vehicle dynamics. So introduction to vehicle dynamics. So one thing, what is dynamic? So why it is called vehicle dynamics? So dynamics is nothing but a study of motion and the force that cause it. In simple words, let me explain it. See, kinematics tells how something moves, but dynamics tells why it moves the way because of a force or a torque. So here we are going to see 6 DO of governance. So which is translation motion in Fx, Fy, Fz axis, and rotational dynamics, which is in Mx, My, and Mz dynamics. So thanks to Newton-Euler equation and rigid body modeling, so these all dynamics are based on Newton-Euler equation. So here in this chapter, we are going to cover by different topics: tires, suspension, steering, and chassis. Before jumping into the systems, let me understand what is a coordinate system. See, we have been learning this coordinate system since our ninth standard. And like, so what is how coordinates? So what are the coordinate system? So in CardMaker coordinate system, the coordinate system called as frames. So as you can see in the images, so there are three frames: frame 0, frame 1, frame 2. So they are used to simply calculation and parameterization for car maker objects, and also able to represent different points of views of car maker objects. So let me explain what is frame zero. So frame zero is a earth fixed origin of a virtual world. Let me take an example. For example, I am standing in the middle of a road, or else let's keep a race car in the middle of a road. When you're seeing the car from the earth perspective of view, then that origin is we call, or that coordinate system we will call as frame zero. Now, what is frame one? So frame one is nothing but it's a coordinate of moving object, like saying like a race car. So race car's coordinates, its own coordinate, we will say it as a frame one. Let me brief you with an example. Let's say the x-axis, the movement in the x-axis, which we consider as a longitudinal dynamics, and the rotational movement, we will call this a roll. When you are seeing the car rotational around the x-axis, we will call it as a roll. Then we will go to y-axis. So the movement, the side to side movement in the y-axis, we will call it as a lateral dynamics. And the rotational around the y-axis, we will call it as a heave or pitch motion. So let me go to z-axis. So in the z-axis, the tra- the ro- the z-axis, the rotational around the z-axis, we will call it as a yaw. Now, as I explained, the key areas of vehicle dynamics are longitudinal dynamics, lateral dynamics, and vertical dynamics. So what is longitudinal dynamics? Simple. Let me explain in a simple, very manner. What is longitudinal dynamics? Just go and stop. So it deals with acceleration and braking and traction forces. So it is influenced by engine torque, gear ratio, and tire slip ratio. So it is modeled using Newton's second law of motion and driveline torque equation. So basically, inertia of some kind of a thing, or force is equal to mass into acceleration. So now, what is lateral dynamics? Let me explain. Lateral dynamics, turn and stay stable. So it is a motion in side to side or across the vehicle path. Governs cornering, stability, steering response force comes from the tire slip, steering geometry, and suspension setup. Vertical dynamics. Vertical dynamics model using quarter car model or full car suspension system. Its key forces are spring force and damping, influenced by road disturbance and unsprung mass and suspension geometry. It governs ride, comfort, pitch, roll, and load transfer. Architectures of forces. Now, let me go through car maker. So, vehicle dynamics is full of calculating the force, calculating the torque, moment of inertia. So, how it is basically in the play of physics max. How car maker is calculating this physics, this max. So, everything comes under a chain of calculation. So, I'm going to explain a vehicle calculation. Let me take an example. Take a steering model. So now I'm applying a 10 Newton meter of torque to the steering wheel. Now it is a calculation of a steering part, rack displacement. So if you're giving a 5 Newton, 10 Newton meter in a steering wheel, then the column, then the pinion angle will rotate and it will make the track to displacement. Next step will be the kinematic part. Now we got the rack position. Next step will be the kinematic part. CarMaker will update of steering state variable, and also it will update all the vehicle body like powertrain and brake state variable. It will calculate all the kinematics and the elastokinematics. As you can see, in the picture force involved in the vehicle model, you can see there are force applying to the wheel carrier, which are brake movement, tire forces, torque, gyroscopic moment, gravity, and some loads. And also every bodies are connected. This is how the kinematics parts are calculated. The next steps will be the force and torque part. parts. Now, as I said, the calculation of aerodynamic force and torque, calculation of suspension elements, force, calculation of inner torque of flexible body, calculation of tire force and torque. Next, this variable are calculated and pushed to kinetic paths. What this kinetic path will do, it will calculate it of generalized force, update the hitch force or the torque or the necessary torques or force, update its load mass, inertia, simply Mesa Verde dynamic calculation. After calculating all the resultant force, the next step will be the integration. So after calculating the force, it will integrate the generalized coordinates. This is how the architecture of force correlate with different part of a vehicle body. Now we will deep down into each subsystem of a vehicle dynamics. I will start by chassis. So chassis. What is chassis? So chassis is a vehicle structural backbone. It supports body, suspension, engine, and drivetrain. The body model is a core of car makers' multi-body vehicle dynamic simulation. Inputs will be vehicle mass, inertia, CG position, aerodynamic coefficient, and it computes vehicle motion. The output will be, as I said, the roll, yaw rate, or the what is the longitudinal acceleration, what is the lateral acceleration. So this is how the chassis will work in CarMaker. I will open CarMaker to explain you in a better understanding way. See, here the vehicle body, it is co-interface with the brake system, steer system, tire, trailer, and powertrain. As you can see, the body, parts of body, vehicle body, all sprung mass beside engine, trim loads, vehicle loads. So these are the vehicle bodies and the parts of the bodies. And one more thing, keep in note that mass geometry. What is mass geometry? The representation of the distribution of mass in a material system is called mass geometry. Inertia properties are associated with this vehicle body, and each four-wheel and wheel carriers will be associated with it. So I have opened my car maker. Let me go to my parameters. Under parameters, I can see an option called car. In this car, you can find a vehicle dataset which contains assembly, body, suspension, steering, tires, brake, powertrain, sensors, and vehicle controls. Coming to chassis. So what is a wheel carrier? So wheel carrier is nothing but a hub of a wheel. So here you can see the front wheel position. It is in 3.4 x meter. So let me take an example and let me take a car. Let me choose this car. Answer. See, now we have a car. Now the position of wheel FRL, it is in 3.517. So if I give some value as 5, as you can see, I have changed the wheel position. So it is necessary and it is compulsory to keep this wheel carrier or wheel position according to your car. Now if I close this and I give the ideal value, now you can see the wheel is in an exact position. So these are the must steps you should follow when you are importing your own race car into IPG car maker. So these are the position around X, Y, and Z, and also the mass of each wheel and the moment of inertia of each wheel. Now go to body. So we have to define the jack FL, FR, and RL, and jack RR. Now here in body, if you go here, keep this structure as rigid. Unless you want your flexible model, you can keep it flexible, but you have to define the correct rotational torsion motion and rotation Y bending moment. If this value changes, then your validation will be changed according to it. So keep it rigid. And if you want to import your own car here, let me give an idea, a solution for it. So now how to import your own chassis or your own race car here. Go to car, go to file, you can find file, give generator. As you can see, there are vehicle classes, vehicle parameters, tires, and if you go to advanced setting, the vehicle body, driving axle, gearbox, steering, engine, transmission, axle suspension, aerodynamics. So since I will give it as a small car and the unloaded weight is like 1125, you can change according to your curb weight of the vehicle and the vehicle length according to your vehicle parameters. Now, if I give generate, now you can see a car has been generated, but you want to import your 3D model, your 3D structure into it. Go to car. Here, main thing, keep a note, take a PNG file. For this picture, you need PNG file in your project folder. So I have taken McLaren MP4 2016 model.png in here. So if I keep it in your project folder. So if you click OK, then your picture will come. But to visualize your car in IPG movie, so you have to go or movie NX. You have to choose between that. So I have chosen select from movie folder. So keep it as in vehicle, 3 movie, 3D under here vehicle. It should be in MOOBJ file. See, now if I run this simulation, see, I have imported my car here, but the wheel carrier position has been changed. So that's why I have initiated in the beginning of this session, in this beginning of this topic, main ensure your wheel carrier position and everything is in the same as you needed. So ensure this wheel carrier position. So this is how you're going to import your 3D model into car maker. The next topic, which is tire dynamics. Tire dynamics is like a vast topic. You have to understand the dynamics because the only relation between the vehicle and the road, the only joining part are tire. Let me take an example. See, I think everyone is watching Formula One. See, Formula One cars are same, like every regulations are same, every car's dynamics are same, but the aerodynamic part will be changed. But the one thing you have been noticed, every team has been keenly watching the tire temperature, tire pressure. You know why they are like they're giving more importance on tire? Because of the grip. See, tire grip plays a crucial role in racing dynamics. Okay. Let me give an example. Have you seen a drift car? Have you seen a drift car? The car's wheel, the car tire has been inverted towards the body. So why it is like? See why race cars have a inclination of the when you seeing from the x-axis perspective, you have seen the angle of tire has been inward or outward in any cars. Why no? See when you are seeing from x-axis, so one sec. So as you can see, See, this is the view from the x-axis. Okay. So as you can see, the tire in a shape of rectangular. So when the car is taking a turn, you can see there is a small gap here. So the tire is not completely patched to the road so that some of the thread has been missed. So some of the percentage of grip has been less. So that's why lesser grip cars would make to understeer or oversteer in a high speed corners, and the grip which is more in the tires which cars will take a high speed corner very easily. Now, how tire dynamics has been modeled in CarMaker. See, CarMaker had made feasible and easier for the user to make a tire dynamics. CarMaker tire models contains of empirical and physical model supported. So there are there are three tire models: IPG tire or real-time tire, which is empirical and measured based, which is TireX format. So what is TireX format? Tire data exchange file. I will explain it. And Pajeka MF tire and Tame tires F tires. I will explain what is one example, IPG tire and real-time tire. If I go here in parameter tire, you can see the tire data set. So you can read the parameter file, what it's saying: real time, RT real time, 195 aspect ratio, 65R, 15-inch tire. So created with IPG tire data set generator. So IPG gives you a feasible option to create your own tire model. Now I'm going to explain how to create a tire model. Simple. Click long press file, click generate, tire data, keep your own name. Let me give 16. Keep TireX format, tire aspect ratio, 16. Inflation pressure, these are all okay. If I give generate, yeah, okay. Now you can see I have created my own tire for 16 inches. And in the model parameters, you can change the standstill model, longitudinal force, and lateral force. What is the standstill model longitudinal force? It's a minimal force to make the tire move, and the relaxation length, and the rolling resistance, kinematics and load force. Now scaling factors, additional parameters. So let me take, so this is how your TIDEX format will be. TIDEX format is like a ASCII data, converted ASCII data of your tire. See, normal width, nominal section width of a tire, 185, aspect ratio, 65, R, and the inch, 16, rim width, everything has been stored in this TIDEX format. So CarMaker will read all the tire data in this file, TIDEX file. So this is how you're going to create your own tire dataset. And you can verify if your tire is performing good by using slip ratio, slip angle, cornering stiffness, and check with longitudinal slip, with the slip angle, longitudinal force. You can check all those parameters with it. Now moving to next part is suspension. Here, suspension plays a crucial role on vehicle dynamics. So, which is a connector, as I said, it's isolate chassis from the road disturbance and manage load transfer during acceleration, braking, cornering. So, before jumping into any suspension designing, what is suspension geometry parameters? See, these are the 6 parameters, geometry parameters, which is camber angle, caster angle, toe angle, kingpin inclination, scrub radius, ride height. What is camber angle? So as I said, the angle between the wheel plane and the vertical axis, like view from it from the x-axis, view the vehicle from the x-axis. So the vehicle is in front of you. You may see the inclination of a tire or a wheel towards or outwards of the vehicle. So if it is inward, then it is a negative, and if it is outward, then it is a positive. if negative cambers improve cornering grip. Let me explain why. See, it is a negative camber. Okay, so when you're turning your car into right, your overall load will shift it to left as the law of inertia. If you're giving a sudden right hand turn, then the load will transfer to left. That means the tire angle, the camber angle will change and it will be in a perfect rectangle. Then it can use its 100% grip. That's why negative camber improve cornering grip. Let me give a live example how to model this negative camber. Okay. Give me a second. Okay. Give me a second. Okay. Right. Okay. 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 Now, as you can see, so as you can see, the tire is perfectly in a rectangular shape. Now, what will I do is like, so you may know about direct variable access. So it is a user where you can change the value of anything in a live simulation. So here, quantities, if you go car, then front left means front left tire. If you go here, choose car.cfl.rx. That means that it is a rotation around x-axis. So if I click this, so for front left tire, I have given 0.05 of radians rule, and front right tire I have given minus. Why minus? Because as from the coordinate system, if it is in x direction, in a positive x direction, then it should be minus. So let me make the car stand still. Okay, stop vehicle. Now, keenly watch on the tire angle. When I give set, you observed a camber angle in this left tire. Then keenly observe if I give set, see, there is a camber angle in both the tires. So if I want to just change the toe angle, toe in, toe out. I think you have all heard about toe in, toe out in F1 cars and even in normal passenger cars. We will have some minimal amount of toe angles. So if you go to CFL and if you go in R as an external, if I give set, see, there is a minimal change in the toe angle. So this is how you're going to change the suspension geometry parameters to get the better grip in the tire model. So that's why in every race in Formula One, you can see every team will change, like some race, some for different tracks, every team will parameterize their suspension geometry according to the corners, like it's a high speed corner or low speed corners. So how has been this suspension has been modeled? It's modeled with quarter core model with sprung and unsprung mass. Now, how we are going to model this suspension and axle? So there are four models. One is linear 2D. So what is linear 2D? Nothing but a suspension model, which is a 2DO model. It's a two-dimensional kinematics depends on the wheel travel and the rack displacement. It can be used to parameterize steered front axle for independent wheel suspension. And what is linear 3DOF? Make a note, linear 3DOF depends on the wheel travel and the steering rack displacement and also the movement of opposite wheel. So linear, what is the difference between the linear 2D model and linear 3D model? Only the degrees of freedom, like dimension, like 2D and 3D. So 2D only depends on the wheel travel and the steering rack displacement. 3D depends on the wheel travel, steering rack displacement, and the movement of opposition of wheel. SKC file is like suspension kinematic file. So contains camber and toe versus travel 3D, define 3D suspension geometry and these things and all. MBS, now we are going to discuss multi-body suspension model where you can model the full multi-body suspension with links, joints and bushing, which will provide you accurate ride and handling behavior. Let me explain how to model this. So if we go to parameters, again car, go to suspension, go to kinematics, play it here. Under the model front, note it is for front. If you go click, you give MBS, here you can see no file has been selected. So I'm going to click this model, open, double wishbone, then open MBS. As you can see, most of the Formula Bharat car use double wishbone axle where you will have a upper A arm and where you have a lower A arm, stabilizer link, and you have steering axle in the front. See, you can see you have designed your own double wishbone axle instead of playing with maths and physics, modeling it. Simple. It's like we are minimizing your time. We are minimizing your time, giving you a feasible solution so that your validation will be perfect. So here you can define the bodies. So double wishbone. So why it is double wishbone? What is like what are the bodies you will find in double wishbone? It will be always double. You can find two wheels, two wheel carriers, two lower wishbone, two upper wishbone, two stabilizer link, two stabilizer bar port, two steering rod, one steering rack, or one steering box or subframe. So it's all come here. So you have joints. You can define the joints, force element, bushing, mapping, everything. And make sure if you have given double wishbone, please make sure to click this length IO. And if you go kinematics, rear, and also we have our own double wishbone rear MBS model. You don't need to model any MBS format. So now everything is ready, everything is set. So now it is necessary to change your double wishbone MBS model. As you can see, what it is saying, please adapt the mass and inertia of the front left wheel carriers in the vehicle to mass, like mass to 18.28, 0.36, every values. So it is necessary to change the mass and the moment of inertia around the x axis, y axis, and the z axis. So we will do that. We will go here, assembly, over here, we will change mass to 18.28, 18.28, 0.336. Okay. Okay, I missed it. Please make sure this length IO should be clicked. Yeah, now we have double wishbone axle is been ready since the car is not in motion, because in the maneuver I didn't give any longitudinal dynamics. And also please note that here in the maneuver, vehicle maneuver also, please note that it is defined as longitudinal dynamics and lateral dynamics. So longitudinal dynamics, you have IPG driver. If you give speed, the IPG driver will drive to that speed, drive backwards, stop vehicles, tracking, and manual. In the manual, you have clutch, throttle, brakes, parking brakes. And in lateral dynamics, it is control. It is used to control your steering action. So now I will leave it to IPG driver. So if you click the box to IPG driver will do the longitudinal dynamics and the lateral dynamics. So I will give stop and start. As you can see, as you can just see the red bar, the red like cylindrical bar, which is increasing. That means the load is heavier. See, the load is heavier on the right side. So you can check, see, the load is heavier on the left side because it's right hand turn. So you can check the slip angle. You can change. You can check how much the spring like spring motion, damping motion. What is the anti squat while braking? What is the anti lift? So everything you can check. What is the yaw rate? So let me illustrate that. So in IPG CarMaker, we have two types of validation. One is through virtual, that is IPG Movie or Movie NX for better rendering. So, and another thing is like IPG control for graphical representation. So if I click IPG control, now I want to check my car's lateral acceleration. So car dot AY, these are user accessible quantities. So if I give car dot AY, see, these are my, this x axis will be time and the y axis will be my car dot acceleration. So now I want to check my front left. Yeah, my front left gen force. See, you have from A to Z, you can verify any terms related to vehicle dynamics in IPG CarMaker through IPG control. So you can see the load, longitudinal slip in the front left tire. You can see, you can verify it. And if you want to take this data into Excel, go here, export file. You can take this data as a CSV file. And now you want to do a model check. So you have given your card. Now you have want to do a changes here. Wait a second, I will erase this. Yeah. Now, if I click model check for this car. If I give start, so it's checking my car. Yeah, yes, yeah. So yeah, here you can see this is the aerodynamics of the car. So this is my car aerodynamics. So engine power, brake, tire, tire load characteristics, suspension force, suspension kinematics, front axle, rear axle. Now we want to check your double wishbone. We have UAQ all for that also. Now if since you have selected double wishbone, suspension front, you can check your stabilizer bar right, link, link R, steering rack, everything you can check in CarMaker. It can be any from A to Z, everything you can validate in CarMaker for in the terms of vehicle dynamics. Now, steering system. Steering system. What is the task of steering system? It's only to define the driver steer influence to the front suspension. So what is the input? Steering wheel angle or steering torque? It will go to steering column. That steering column will have a pinion. It will turn the pinion into rack. So since the formula bar is called all are purely mechanicals, we will have a pinion and rack displacement. And what is the vehicle suspension do to the steering system? How influence it? So how the wheel carrier is influenced due to the steering system, and at the final, what is the tire angle which is influenced by the steering system. So if you go to car parameters, car, steering, do not change anything. So now you can see rack travel to steering pinion angle. That means for 87 radians, the rack travel will move 1 meter. So if you want to model your steering column also, give dynamic steer ratio, which is gen torque, and go to mechanical model and give your all your inertia, rotational damping, mass of steering rack, translational damping, anything. So if you're having any power assist module kind of hydraulic power assist or electric power assist, click prefer with power steering, go to power assist model. Here you can check hydraulic power steering or electric power steering to rack, column, or your own DVA user function. Here you can model your steering system. So now you can see in the scenario editor, I have created a lab. So I've created my car, my own car, and the final most point is like load. See, the driver load is not accurate. So what will I do is like, I will give some 2.5. Then now you can see the driver load is perfectly matched where the driver will sit in an actual race car. Now I have designed a body. Now we have designed the body. We have designed the suspension. We have designed the tire. We have designed the steering system. So next step is like get the car into the track, get the car into the track and validate it. That's how we will use IPG Car Maker to validate vehicle dynamics. Thank you. Hello.
Yes, thank you, Mateshwaran, for that incredibly insightful session. I'm sure
Yeah.
that our audience has gained a deeper understanding of how simulation tools can, redefine the way that they approach vehicle design and validation.
Yes.
So we will now open the table for Q&A.
Okay.
To our audience on YouTube, if you have any questions that you would like the speaker to address, feel free to put in your questions in the chat box and we'll get them answered.
Okay.
Mateshwaran, there is a question as to where one can request the software. Although
Yeah,
I've put the link on the chat already, you can just maybe explain how one can request.
okay. So the thing is like, you can go here, type IPG CarMaker. Here, go to support, test license, request test license. It's simple. It will come to us and we will provide you test license. So I will share this thing in the chat box. So I have provided, yeah. Is there any other question? Feel free to ask question.
Thanks for showing those steps. I've put in the link on chat as to how they
Okay.
can request access. We'll wait for another 2 minutes to see if we
Yeah.
get any more questions, and if not, then we can probably wrap up the session.
Okay, fine.
All right. Looks like we don't have any more questions.
Okay.
So thank you once again, Mateshwaran, for
Yeah.
sharing your knowledge and giving us
And
such practical insights. Yes. Do you have anything to add?
yeah, and also I will share one more, which is support at IPG.
Sure. There is another question if there are any tutorials to learn the software.
Yeah, that's the thing I'm going to explain in the last part. There
Sure.
are documentation and video which is available in YouTube. In the documentation, if you open CarMaker GUI, if you go to help, you can find the quick start guide, the user guide, product example, reference manual, programmer's guide, installation guide, and IPG driver, IPG movie, movie index, and even also we produce additional documents for IPG control and IPG road SIMnet and everything we have provide the documentation. And if you go to YouTube and if you type IPG car maker tutorial, you can find a lot of videos over there.
All right. Thank you for answering that. Is
Yeah.
there anything else you would like to add?
Yeah, all the best for your competition. So do well, learn lots of more stuff, and all the best for your upcoming competition.
Thank you, Mateshwaran.
Thank
To
you.
everyone, that brings us to the end of today's Formula Bharat Academy session. On behalf of the Formula Bharat team, I would like to extend a heartfelt thanks to IPG Automotive India and Mateshwaran for joining us today and contributing towards our community's learning journey. Stay tuned for upcoming sessions under the Formula Bharat Academy series and keep building, learning, and innovating. Thank you for joining us today.
Thank you.